Okay, we've got one more video on quadratic inequalities. So we're going to go through these three here, solve those, and hopefully by then you'll have a good understanding of your quadratic inequalities. Now, looking at the first one, following on from what we did last time, the first thing we're going to do is try to solve it, find the roots, and then we can make a sketch. So for this one, does it factorize? That's the first thing. Let's have a look. So 2x and 2x, if it's going to factorize, 3 and 1, there we go. So that factorizes there quite nicely. So then for this bracket, we're going to have x is equal to a half, and for this one here, x is equal to 3/2. Okay, fantastic. Now that we've got our roots, we go and make a sketch. It's a nice little sketch in there. A half is about here, and we'll say 3/2 about there. And again, we'll exaggerate the way that we draw this. Something like that. Now remember, this is a half, so 0, -1, and numbers like that are going this way, so -2. And then going off in this direction, 3/2, that's 1.5. So then we've got maybe like 2 and 3 and 4, etc. as you go off in that direction. Now what we needed to do is find where this graph is less than or equal to 0. So the region that we're interested in, or the part of the line that we're interested in, is this here. So we want this part of the curve because that's underneath the x-axis. So to describe this region here, what we can do is say this. As you go off this way, what's happening to the x values? They're getting, well, smaller than or equal to 3/2 this time. And then as you go off this way, remember that's a half, so as you go off in that direction, the x values are getting bigger than or equal to a half. So we can give our answer like this. If you wanted to give it using some set notation, then you could say that x is greater than or equal to a half, or less than or equal to 3/2. So that's just as one big set. Or we could split them up and we can give it like this. So we can say that here x needs to be, first of all, greater than or equal to a half. And then it intersects with where x is less than or equal to 3/2. So again, three different ways there of giving our answer. And remember that intersection bit is because in here, the x values intersect, they worked for both. Now, for question number 2 then. To begin with, I think we need to multiply that all by x squared because it's not looking very good at the moment. So what we'll do, multiply absolutely everything by x squared. So if we multiply this here by x squared, we'll just have 3. And if you multiply this by x squared, then we'll have, well, 5x squared over x. So that's just 5x. And then multiply the 2 by x squared, and we have 2x squared. Next thing we could do is take everything across to the right hand side. So we'll have 0 left over here, and we'll have 2x squared minus 5x and minus 3 left over there. And now what I want to do with this is try to, well, factorize it, I guess. So let's try and factorize this. So 2x and x, I think it's going to be 3, 1, minus, and plus. That should work there. So remember, at this stage, I just want to find the roots to create a good sketch. So we'll set this equal to 0 for now, and we'll say x here is minus a half, and x is equal to 3. So now we can create our sketch. So minus a half over here, and 3 way over there. There we go. So here's our sketch. So 3, 4, 5 on this side, 2, 1, 0 in here, and then maybe minus 1, minus 2 over there. Now, if we look at this part, what were we trying to find? We were trying to find where this graph is greater than or equal to 0. So we want the parts that are above the x-axis. So this part and this part in here. So what's happening to my x values as we go off in that direction there? Well, they're getting bigger than or equal to 3. And then on this side, what's happening as you go off in this direction? The x numbers are getting smaller than, or they're equal to minus a half. And so this time, if you wanted to represent this using some set notation, you can see there's no overlap between the values, right? So these values are completely separate to these, unlike it was here. So they overlapped quite nicely. So for this, what we need to do is, first of all, we've got some x values here which are less than or equal to minus a half. And then we've also got x values which are greater than or equal to 3. But because there's no intersection between the values, what we want to use is a union symbol like this. So that's how we could give that one there. Now, for the last one, we've got to find a set of values that work for both of those quadratics. So it's not just the same as these where we've just solved and we've got one set and we're done. We've got to find a set of values that's going to work for both. So let's get cracking. Now, for the first one, we'll go find the roots again, make a sketch, then we solve it. So this one here. So we've got x squared minus 2x minus 3 is less than 0. We'll factorize first to help us get the roots. So that's going to be minus 3 plus 1. And so x is equal to 3 and x is equal to minus 1. There we go. Now, what can we do with that? We can make a sketch. So let's make a sketch over here. So we've got 3 and then minus 1. We've got 0 in the middle, 1, 2. On this side minus 2 and on that side 4. So we'll make a sketch there. There we are. And what we need to do is find where this graph is less than 0. So underneath the x-axis. So we're talking about this region in here. And now what can we see? Those x values are less than 3, but they're also greater than minus 1. So those are the values that's going to work for this quadratic. Now what we'll do is find some values that work for the second one. So that's x squared minus 3x plus 2 is greater than 0. So we'll factorize first to find our roots again. We'll have, I think, minus 2 minus 1. And so x would equal 2 and x would equal 1. Okay, fab. And then what we'll do, we'll get a nice sketching. So 1 and then 2 and then we'll say 3 over here. Oops. 3 and 4 and on this side 0, minus 1, etc. And then let's draw our quadratic. There we are. Now what we're trying to find with this is where the graph is greater than 0. So we need to talk about this region here and this part here. So these two bits on the line. Now for this part, this is where the x values are less than 1. But on that side there, that's where the x values, as you go off that way, the x values get bigger than 2. Okay, so what we've got so far is we've got values that work for that quadratic, we've got values that work for this quadratic. But what we need are values that's going to work for both. So how are we going to get that? Well, I think the best thing to do is usually draw a number line. So if we draw a number line like this, we'll have maybe, let's start at minus 3. Then we go minus 2, minus 1, 0, 1, 2, 3, and 4. Okay, so what we'll do to begin with is we'll show this inequality on the top of the number line in blue. So the x values here have to be bigger than minus 1, but they have to be smaller than 3. So we're talking about this region here. So all of the values in here are going to work for that quadratic at the top. Now in red, what we'll do is put these two inequalities on in red. So x is smaller than 1, so that means there, and smaller than 1 going in that direction. And x is greater than 2, so open circle there and going off in that direction. And so what we can see is the bits that are going to work for both is where there's overlap between the two lines. And hopefully you can see that there is all this up to this point. And so what's that? That's where the x values are smaller than 1 but greater than minus 1. And then there's overlap over here as well. So again, this part. So what's going on there? Well, the x values there are getting bigger than 2. So x is greater than 2, but smaller than 3. Okay, fantastic. So there it is. And then if we put this into some set notation, then what we could do is list it like this. We could say minus 1 is less than x, which is less than 1. And then that's in union with x is, oh, sorry, that's supposed to be 2, is less than x, which is less than 3. And then we can close that off in there. Okay, perfect. That's that one solved. So you need an extra little step there, and hopefully you can see that if you put a number line out, you can actually see quite easily the parts that apply to both of these inequalities. So I hope that all makes sense, and I'll see you in the next video.